The sea covers most of our planet. It looks calm and steady from a distance, a vast expanse of blue that seems eternal and unchanging. But the sea has one key secret, a fundamental ingredient that shapes our world in ways we often overlook. The water in the sea is salty. This simple fact is the foundation for so much of what happens on Earth. It shapes life in the deep. It shapes the climate of entire continents. It even shapes the very way water moves across the globe. A silent engine driving our planet's systems. And if that one ingredient were to vanish, the world as we know it would begin to unravel in an instant. But why is the ocean salty in the first place? The story begins with rain. Rain falls on the land, mountains, plains, ancient rock formations. Water moves, flowing in tiny rivulets and great rivers. It gently erodes the land it crosses. It picks up tiny, invisible bits of minerals from the rocks. Rivers carry these dissolved minerals to the sea. Salt, sodium chloride, is one of these minerals. Over millions upon millions of years, salt has accumulated in the ocean basins. The sun warms the sea. The wind blows across its surface. Evaporation lifts fresh water into the sky. The heavier salts remain, growing more concentrated. This salinity matters a great deal. Countless forms of life have evolved to thrive in this chemical environment. Plankton, the tiniest sea plants and animals, form the base of the marine food web. Fish, whales, and other great sea mammals, coral reefs, vibrant underwater cities, require a narrow salinity range to grow. Salt also affects how water moves. Saltier water is denser, heavier than fresh water. So, imagine a profound, almost unthinkable change. Imagine all the seawater in a single moment becoming fresh. Not just less salty, but completely stripped of mineral content, like rainwater. It's a hard idea to picture, a fantasy on a planetary scale. But exploring this impossible scenario shows how much ocean salt matters. It reveals the intricate connections that hold our world in a delicate balance, and what we stand to lose if that balance is disturbed. It really puts things into perspective. If the ocean's salt were to vanish, the first consequences would be immediate and invisible, unfolding on a chemical level. The sea would undergo a sudden and catastrophic transformation. Salt is not just one substance. It is a complex mixture of many dissolved mineral ions: sodium chloride, sulfates, magnesium, calcium, potassium, and other minerals. If all these were to disappear, the very chemistry of the sea would be rewritten in an instant. The countless dissolved minerals many marine species depend upon would simply be gone, building shells, firing nerve impulses. The physical properties of the water would also change dramatically. The density of seawater would plummet. An average liter of ocean water is about 2.5% heavier than a liter of fresh water, a small difference that has enormous global implications. Without its salt, the ocean would become uniformly less dense overnight. This would fundamentally alter the way water layers are structured. The natural stratification would be disrupted. The intricate mixing of surface water with the deep would change its rhythm, affecting the transport of nutrients and oxygen. This chemical shift would create a cascade: destabilized pH buffering, altered carbon dioxide absorption. With the ocean's chemistry in turmoil, the next and most visible tragedy would be the collapse of marine life. The vast majority of sea creatures are osmoregulators, exquisitely adapted to maintain a stable internal balance of salt and water within a salty environment. If that environment suddenly became fresh, their cells would be thrown into a fatal crisis. For a typical saltwater fish, fresh water would rush in through gills and skin in a process called osmosis. Its cells would swell and burst. Its kidneys, designed to expel excess salt, would be overwhelmed. For millions of fish, death would come within hours. The foundation of the marine food web would crumble almost instantly. Phytoplankton produce more than half of the world's oxygen. They feed countless other creatures, yet they're highly sensitive to salinity. A sudden shift to fresh water would kill them off in unimaginable numbers, turning vast swathes of the ocean into a sterile soup. Zooplankton would starve, small fish would disappear, crustaceans and other grazers would vanish. The collapse would ripple upwards to larger predators: tuna, sharks, dolphins, seals. Coral reefs, bustling metropolises, depend on precise temperature and salinity. Fresh water would be a death sentence. Coral polyps would die, leaving ghostly skeletons. Thousands of species that rely on reefs for food, shelter, and breeding grounds would have nowhere to go. The vibrant sounds would fade into eerie silence. Trillions of dead organisms, from the smallest plankton to the largest whales, sink and begin to decompose. Decomposing bacteria consume enormous oxygen. The result: rapid expansion of anoxic dead zones, vast regions with no oxygen. Any remaining creatures would suffocate. The ocean would become a planet-sized graveyard, depths filled with decay, surface strangely quiet. It would be devastating. Beyond the immediate biological devastation, the freshening of the oceans would trigger a profound disruption of the planet's climate engine. The great ocean currents act like a global circulatory system. They depend on differences in water density, from temperature and salinity. Cold, salty water is very dense and sinks. Warm, less salty water stays near the surface. That drives the thermohaline circulation, the great ocean conveyor belt, moving huge amounts of heat around the globe. If the oceans lost their salt, that density difference would vanish. Polar waters would stay cold but not salty enough to sink. The engine would sputter and stop. In the North Atlantic, sinking cold, salty water pulls warm surface water north. That's why Western Europe is relatively mild. Without that heat, the United Kingdom and Scandinavia could plunge into much colder winters and shorter growing seasons. The effects would be global, not just local. Deep water circulation stopping would trap heat in the tropics. Equatorial waters would warm significantly. That fuels stronger tropical storms and hurricanes. Coastal communities would face more frequent, more powerful storms, causing devastating flooding and widespread destruction. Vertical movement of water would also be disrupted, vital to marine life. Upwelling of deep, nutrient-rich water sustains fisheries like Peru's. Driven by winds and density, these zones could weaken or vanish. Nutrients would stay locked deep. Plankton blooms would fail. Surface waters would be starved of life. Fisheries would collapse with devastating economic and social consequences. The planet's climate would swing to extremes, colder at the poles and hotter, more volatile at the equator. Altered temperature gradients would change jet stream behavior, bringing unseasonal weather and prolonged stagnant patterns like relentless heat waves or persistent cold spells. The water cycle, the continuous movement of water on, above, and below the surface of the Earth, is intimately linked to the ocean. A salt-free ocean would alter this cycle in fundamental and unpredictable ways. Evaporation rates are influenced by salinity. Fresh water evaporates slightly faster than salt water. A global freshening would increase moisture entering the atmosphere. That might sound like more rain, but the reality would be far more complex and chaotic. More moisture doesn't mean rain falls evenly. Cloud formation itself could be affected. Tiny particles that droplets condense around often include sea salt aerosols, kicked into the air by wind and waves. Without that supply, cloud formation over the oceans would change. Clouds might form and behave differently, changing how much sunlight they reflect or how much heat they trap. The result, a radical redistribution of rainfall. Predictable rainy seasons could plunge into prolonged drought. Atmospheric rivers that once carried moisture could be diverted elsewhere. Conversely, other areas might face unprecedented, catastrophic flooding. The great agricultural breadbaskets would be jeopardized. The world's fresh water supply would become dangerously erratic and unpredictable, threatening ecosystems and human civilizations alike. Altered temperature gradients would change jet streams, shifting their paths and bringing unseasonal weather. We might see prolonged stagnant weather, relentless heat waves, or persistent cold spells. The predictable rhythm of the seasons would be lost to a new, chaotic climate regime. For humanity, the consequences of a freshened ocean would be catastrophic, touching every aspect of our civilization. The most immediate impact would be on food security. Billions rely on the ocean as their primary source of protein. With the collapse of marine ecosystems, the global fishing industry would cease to exist overnight. Coastal communities from Southeast Asia to West Africa to South America, whose cultures and economies are built around fishing, would face total ruin. The disappearance of this vital food source would trigger widespread famine and malnutrition on an unimaginable scale. The economic fallout would extend far beyond fisheries. While ships could sail on a fresh ocean, port cities would be in chaos. Tourism tied to beaches, reefs, and marine wildlife would collapse. The cascading effects would ripple through the global economy, disrupting supply chains, crashing markets, and erasing trillions in value. The cost of adapting would be staggering. As the climate shifts and fresh water sources become unreliable, unprecedented human migration would follow, from drought-stricken, flooded, and extreme cold regions. These climate refugees would strain resources in more stable regions, likely triggering conflict over land, water, and food. Beyond starvation, lack of clean drinking water would spread disease. Shifting temperatures and rainfall could expand mosquito-borne illness. The psychological toll would be immense. Humanity stranded on the shores of a dead, alien sea. Faced with such a planetary catastrophe, the question arises: could nature fix this? Could the oceans ever become salty again on their own? The answer is yes, but on a timescale difficult to comprehend. The same slow erosion and river transport would begin again, tiny amounts of salt starting their journey to the sea. It took hundreds of millions of years to reach today's salinity. Replenishing a freshwater ocean would take an equally vast time, like filling a swimming pool with an eyedropper. For all practical purposes relevant to human existence, the change would be permanent. Could humanity intervene? The oceans contain 50 quadrillion tons of dissolved salts. Mining, producing, and evenly distributing that amount would demand energy and logistics far beyond any historical undertaking. The environmental side effects alone would likely cause new disasters. Even if we could dump the salt back, ecosystems, currents, and climate would not just snap back. Rebuilding a planetary system isn't like reassembling a machine. Once the delicate balance is broken, the path back isn't guaranteed. The lesson is clear: prevention is far more realistic than cure. This journey into an imagined freshwater ocean reminds us, the Earth's systems are profoundly interconnected. The salt in the sea seems small, yet it is a linchpin holding together marine life, global climate, and human civilization. Pull this one thread, and the tapestry unravels. Life, weather, and the physical planet are partners in a delicate, continuous dance. These systems were built over eons through countless small interactions. They are robust to small changes, but vulnerable to large, rapid shocks. We live inside this precious balance, often taking it for granted. Unseen complexity gives us stable climate, breathable air, and a living ocean. We can't desalinate the ocean overnight, but we can shift its chemistry by warming, acidifying, and polluting it. Each action pushes the system toward tipping points where change is rapid and irreversible. This shouldn't lead to despair, but to responsibility. By protecting reefs, restoring habitats, and cutting emissions, we help preserve the dance of life, so the ocean remains the vibrant, life-giving heart of Earth for generations to come.